So hello, we will start just in a second. The course that we are gonna run will be in English language because we have quite a few students that are international that will be also joining us. And we'll do this in a Google Live format. You're welcome to write any questions in the chat, and also if you can hear me now, right? If you can hear me and see me well, please press a like or signal somehow plus minus or something in the chat. So can you hear me well and see? Let's see, plus minus, let me know in the chat. Also, I see some question there. By the way, of course, I'll ask questions in Latvian as well, as we have a significant part of students Latvians. Unfortunately, this time this will be in English, but definitely ask questions in Latvian as well. So, yep, so there's question about different courses, and there is a little bit of chaos, right? With the course management, because there is the restructuration of the university, and we need to bear with us, unfortunately. So, but you should not be worried. Like any person who was in the previous courses and now moved to this course, which will not be based on computer programming and mathematical equations. So you can finish this course, and you would get the mark in the other one, because we have a little bit of structural issues. So that's that. What else? So the structure of the course, so what you're seeing right now will be recorded, and you can look it up this later as well. But the structure of the course will be, I think, about like we'll see how many lectures we can manage. Actually, let me calculate a little bit. Might be that we will not be every week, but we'll try to do every week. Plus, also might need to change the time of the day. I will do some poll, where we can vote for better time of the day and day itself in the Moodle, my YellowRobot Moodle. I will post the poll so you can vote what time you want to have these better, because I know there is one group of many groups that have added here have significant problem of doing this time on Mondays, but you'll see what time we can manage to find that fits the most of you. We'll try to do this probably in the evening, because many students have other lectures or work. So, but we'll try not to, try to find some time that works. So let me check. So if this is 1, 2, 3, 4, 5, 6, 7, 8. So depending on the on the exam period in January. So optimally, I think what I had, let me check how many lectures I was planning to do for this course. Optimally, it would be 10 lectures, but might be that we will do 8. But these 8 will be kind of, I think, the main ones. We will see at the end the plan for this. And we will have the exam at the end. Either I will find some platform that allows to do exam in the way that you cannot use generative or AI models to respond on questions, or we will do this in person on paper, but I'll check that out. Of course, at the same time, I'm not intending to do this to make this too difficult. This is for your own benefit, because you will see in a second that any person nowadays should learn these things. But I'll think about how to do the exam meaningful way, because if I will give you just A, B, C, D answers, or any kind of like question type of exam, or God forbid essays, which is very bad today nowadays, then you will just generate all of the answers, and this will be useless. So we'll try not to do this. We'll try to make it in a meaningful way so that you would switch your brain into training mode, that you can learn things and then try to answer these things, rather than just use the tools that I will show you, because I will show you in this course all of the tools that you can automate any kind of exams, basically, that I would give you digitally. That's why I'm thinking the ways how to do this properly. And of course, in general, I'll be talking about your own motivation and the ability to learn these things, because this is something that you will use in your professional life for sure, 100%. And there's no profession that is safe from this, and you will see in a second. Okay, so we'll see. We have a decent amount of people joining. Just one like so far. We'll see if you like it afterwards, right? So, but yeah. So let's jump in. The AI nowadays can write, right, and speak and read and do all of the intelligent things, right? So this is the preface. And to start our journey, so this will be the introduction session. We'll show you why it is super important to learn all of this and what you can do already in the businesses with these models and technologies. So to understand the artificial intelligence nowadays, I always show this picture. Maybe some of you have seen it already, but might be that some people have not. Actually, I will check if can I get poll in. Yeah, I can get poll. That's excellent. That is beautiful. So this is the the meme, right? Like a picture metaphor of what I found on social media about AI. And to understand this, we need to understand what Scooby-Doo is. Hopefully you understand what Scooby-Doo is. Let's check if poll function works in YouTube. Do you know what is Scooby-Doo cartoon? If you have not seen the cartoon, not sure about what's happening there, then just respond no, so that I need to then explain more. But yes, please vote in the poll. Do you see the poll? Because I used this for first time, this function. So let's try also in the chat. Do you see voting poll in YouTube? Let's see. Not in the poll. I don't see the answers actually. I just see 100%. This is not okay. You see the poll. That's good. Oh no, I see the votes. 16 votes, 17 votes. But everybody says yes. Okay, excellent. Now I understand. Now I start to understand how to use that function. Not very intuitive. The YouTube UX developers could do better job here. But okay, so I see 18 votes of 20 something, and everybody says that no, what is Scooby-Doo? Okay, that's good. So let's close this poll. So I ended that poll. Okay, cool. This shows some results. Okay, so Scooby-Doo. So I don't need to explain in super detail about Scooby-Doo. So here, what we have is the metaphor that the Scooby-Doo gang, the Scooby-Doo is dog, and this is the team, and they basically capture the monster. In this case, the monster is Sophia, the advanced AI. And if you know Scooby-Doo, they usually capture the monster right at the end of the episode. So, for example, there is a hotel in some kind of forest, and there is a ghost that is trying to scare away visitors, right? And then the team catches the ghost and then takes off the mask. And by the way, the ghost is there because there is a gold dug under the hotel, right? Or something like that. So, and then team takes off the mask of the ghost, right? And what is under the mask? So what usually is under the mask of monster in Scooby do? So can anyone type in? What do you think? So for example, there is another example. There is like octopus that is coming out of the sea on night and again scaring away people, or let's say taking some kind of treasure or something, and then they catch the octopus at the end. Great, thank you. The one person is answering already. Human, you were the first one. That's nice. Can I press like? Pin, 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 pin. Don't think I have any nice emotions that I can give you back, but thank you. Yes, this is correct. So the human, there's no monster, right? There's no monster, there's just human behind the mask. So why this is important? I'm trying to, right, funny. So I'm trying to make a point here. So people think that when you capture this advanced AI monster, Sophia, there is actually such an intellectual robot called Sophia with a human mimicking face, facial features. I actually saw this kind of robot just recently in Dubai GITEX conference. So, and then when you take off the mask, there is full of if statements and rules, right? So, and it's not that scary at all, right? So basically, when it's captured, take off the mask, it's not a monster, it's just full of if statements. So, my question here for the audience, for your current role, like understanding of the AI, would you agree on this metaphor? So let me write this metaphor. So poll. So I started the poll. So would you agree on this metaphor or meme, right? Yes or no? And if no, then you could maybe type in some comments. Why do you think that would not be the case? If yes, then it's yes. So I know we have. By the way, I don't see who is voting what on the poll, so you don't need to be embarrassed at all. You just can vote whatever and don't be scared of repercussions, right? But at the same time, it would be really nice if somebody wants to share why not, if not. So we have overwhelmingly yes for now. Don't they use, so there is a one good direction already given. Thank you, Maris. So he is hinting that they could use neural networks as well. But let's wait for everyone, and let's try to get some more feedback. Right now there is less votes than I asked about Scooby-Doo. So either we are starting to drop some participation or people didn't get the metaphor. When I'm doing this in person, I always ask people first to understand for sure that they understand the metaphor, because there's many who kind of, not many, but there are always some who don't understand this. Okay, so at least so 87% of 15 votes says yes. So let me end this poll. Okay, so the reality is this: if I show this exact metaphor in question to the Riga Business School, for example, we always have about the same results, where almost everybody says yes, and then there is some people who says it cannot be that simple. The AI somehow learns things. It is not really. It should be something more there. So, but if I show the same picture for mathematics master students in RTU, like nobody ever says yes. Like they all understand that ChatGPT, that Apple Face ID, that Robot Sophia, that all of these AI, more really advanced AI systems nowadays is something else. on what it is, and this is fundamentally to understand to all of the tools that we're going to use in this course. So what it is actually, this is this on the right side, but please don't blank out, like this will be just the one equation in this presentation. There will not be many other equations. Also, you don't need to, as I said in the very beginning of the course, this will not be based on mathematical equations, this course, where you will use the AND tools and the benefits, not build the AI models themselves. There is another course where some of you came from, where we are learning how to build these tools. Here we were learning how to use them. So what we see here is the model that is similar to ChatGPT or any other AI model that is nowadays widely used. So the idea is that you don't see any if statements whatsoever. There is no programming rules. Nobody programmed AI. This is completely wrong approach to look at the AI nowadays. So the input is the X, for example, and this could be what Sophia sees, the visual image, picture, right? The photo, and from the camera, from the eyes. And in the bottom, H is what Sophia does. So this is like a probability distribution of different activities, actions that the model could take. For example, it could be go left 70%, go right 20%, say goodbye 10%, say hello 0%, and so on. Like it could do many different things. It could predict actions, what to do. It could predict words. It could predict even another picture. So Sophia could see the road, and then the picture comes out with segmentations that it sees that, okay, there is the flower pot, there is the chair. So it can be anything as an input and anything as an output. That's first significant thing to realize about nowadays AI. The other thing is that you can see there is no if statements, but there is a mathematical algebra, linear algebra function, like operators, and the process how this is trained. It's called backpropagation in most cases, and this is based on calculus, or in Latvian augstākā matemātika. So, and just from the algebra, you should understand that there is the coefficients, right? So the X is the input, H is the output, and then there is the mathematical functions like exponents, sigmoids, tan H, and so on, and there is a coefficients. And coefficients, if we find these coefficients, then we can make this model behave intellectually properly, like in intelligent way. So basically. So and the promise, by the way, is in the future with the quantum computing that we will be able to find these coefficients immediately. Nowadays, it is done in some different way. So this theory, how to build these mathematical models, these are mathematical function graphs. They are not programming functions, but mathematical, has been around since early 90s. By the way, just recently, the Geoffrey Hinton, who was the inventor of the backpropagation method, was awarded by Nobel Prize. And there is no Nobel Prize, this was just this year, there is no Nobel Prize for deep learning, for AI, but there is Nobel Prize for, let's say, medical Nobel Prize, I think, or biology. And he got that one because these methods have been used in AlphaFold, Google model that was able to predict protein folding better than any human being. And basically, these models are really fantastic. So what happened is that in early 90s, there were this mathematical function theory, but the data sets were really small. Those days, there were 200 megabyte datasets at most, image datasets. Nowadays, we have 200 gigabyte or even 200 terabyte datasets of images. Then the computing power, right? Those days, the supercomputer was as powerful as my smartphone, right? Nowadays, the picture here is from RTU Riga campus supercomputer, where you have tons of GPU cards plugged into the HPC cluster. And basically those are the kind of the similar video cards as you would have for computer gaming, but they are many and large memory size. So, and what happens if you have huge data, you have the huge computing power, and you have that mathematics from 90s. By the way, when many founders of deep learning methods tried to do this in early 90s, people laughed about them. Like there is another one, Jan LeCun, who is now he made one of the first image classification models using these methods in the early 90s for handwriting recognition. Those days people laughed about him, and nowadays basically he is the Face Meta AI director and one of the world-known founders of these methods. And he's actually done a lot of great work. So what's happened? We combine this huge data, huge compute power, this mathematics, which in the last about 10 years have been developed further. Then we get from unstructured data, structured data. So this is another huge paradigm shift that many people nowadays still do not realize, is that for AI nowadays, we don't need structured data. This is huge thing, because for the last 30 years, everybody was saying that if you want to do the AI models, you need to first invest a huge amount of money to make your data clean, structured, and so on. Nowadays, the AI is structuring data for you, not the other way around. So, but to be fair, if you use it with unstructured data to get structured data, like in this case, you have all sorts of pictures, and now comes out all of the boats together, horses together, cars together, so on. Then this precision will be in human terms about 80% maximum. So you would get 80% precision from unstructured data in most cases. But then if you have a little bit of labels on the left side, so you just add not only the data but also some human labels, you can get immediately 90.9% accuracy. Of course, it will never be 100%. It could be very close to 100% if you have a huge amount of data, but these models, they are approximaters. They are not exact solution. And it also makes us think about that humans are also not always 100% accurate. And if humans build the rule-based systems, they will also have errors. It's just that we will have more control over that rule-based system. In these AI models, there is a little bit less control, but at the same time, there is the basically, it is not always the black box. I actually have idea that I need to show another slide to you. I will need to make a quick break a little bit later, just for 30 seconds, to find another slide to show you that the AI nowadays is not a black box. Okay, cool. Let's go further. If you have any questions so far, we'll jump in. So in the chat, you can write. So the history goes like this. In the 50s, there was the promise that with the Rosenblatt and other American researchers that will build artificial human brains using the perceptrons. So though mathematics at those times were really poor, they were so far away from what actual neural networks are, they were even not comparable properly. Nowadays, I would also argue strongly, and many researchers would also agree, that artificial neural networks that we have nowadays in the ChatGPT and all sorts of models, they are also very far away from human neural networks. They are basically similar only in the name. The way how mathematically and process-wise it operates, it's completely different. It's the same way how genetic algorithms in computer science is completely different than real genetic algorithms. So there is a little bit of, some kind of inspiration of the biological process, but this is completely not similar at all to biological process. As you saw before in the mathematical equations, there is no notion of, let's say, accumulating impulse time or something like that, or also the way how networks connect to each other. So that's that. But then they promised and it didn't work. And then there was a first AI winter. So basically they promised, it didn't work. It was a hype, and then it went down. And then in the 80s, basically 70s, 80s, there was another way how to do this with the fuzzy logic and expert systems. And this is the resulted in first self-driving cars, like on the left in 1975 from MIT, where if you walked into the room, the self-driving car, quote unquote, would drive over you. So because it was not programmed to react on some kind of unexpected obstacles, there was a manual feature engineering and so on. So it didn't work again. And then there was a next AI winter, just overlapping with the significant fundamental research that was launching the new revolution nowadays. So, and then during the 90s and 20s, the thing was that it was based on very weak machine learning models because there were not enough data and compute power. But nowadays, since last 2010, like 2010, 2020 onwards, we have a huge amount of data, and we have very, very powerful computing based on GPUs, on graphical processing units, not CPUs. We'll talk about this a little bit later. So, and what it enabled us to do is to build things like Tesla full self-driving car or Waymo full self-driving car. Literally a month ago was in San Francisco driving with Waymo, which is LiDAR-based self-driving car in San Francisco. So you don't need, there's no driver sitting there. You just say where you want to go, and it actually goes quite aggressively. I actually have some videos. I will post them maybe later in my some social media, so you can make sure that this is true. So and it is perfectly driving. Like there was all sorts of situations on the road, people running, unexpected turns, whatever. There was never any mistake with that car while I was using it many times. The same goes also for Tesla full self-driving car. People or press who is saying that we are very far away from full self-driving car are the people who never have driven Tesla FSD. I was also driving Tesla FSD in Denver, America. So I was the first time in the city. I didn't know where to exactly go, in which line should I stay, and how to get to some specific address. I just entered the address, hold a little bit on the wheel, and the car drove me through the traffic jams, through the unpredictable situations, whatever, to the addresses where I wanted to go. I didn't need to worry that if I turn in the wrong place or so ever. So there is any person who have tried these systems themselves and see also the statistical data how rarely they fail. Actually, they fail on the number of Tesla cars there are. The failures are insignificant so in the count. They understand that in near future, like logistics between the cities will be automated, and there will be robot taxis, and this is something that is coming and is already here. So it's just not here in the Eastern Europe, but in America, in a couple of cities, it's already reality. So you can pay money in the app and drive with the robot taxi. This is the reality, basically, in San Francisco, for example. So no driver at the wheel. So the breakdown of these AI systems is that there is this overarching term, artificial intelligence, which is based on these old systems, expert and fuzzy logics. So then there is machine learning, which was in the 90s, decision trees, which we will look also a little bit how these things work, the clustering techniques, support vector machines, so on. These are also good, but they are kind of weak, but they are very good. So, and then there are the deep learning methods, which run all of the world nowadays, because these are the kind of force that is making these things to work. Without the deep learning methods, all other methods are not able to achieve any results that we are expecting these systems to have. And in these deep learning methods, there's image classifiers, there's all sorts of classifiers, regression models, time series models, reinforcement models, generative models, and so on. And then in the middle, there is this ChatGPT, which is subsection of time series models, which we will look at as well. So how this works, we need to not program model, like with if rules and statements, but we need to train model. And this is model training. Model train is not basically looking at models, but actually doing this a little bit in mathematics. So how you do this in the mathematics is that basically you split your dataset into training and test dataset. You always need to have, and this is something as a business owners or process managers you should be aware of. You always need to have some kind of test or validation dataset which is not given to the developers who make AI models, or if you make your own AI model with some kind of tools, you never give this dataset to the model. Basically, this should be like your gold standard of evaluating if the model learned something. If you don't have a split of the test and training dataset, then mathematical models will learn every single sample by heart. Basically, it will be able to recognize every picture in your whole dataset what it is, but it will not understand the meaning behind the pictures. It is only possible to train the meaning behind the pictures if you split dataset and train model, make the model learn only from the training set, and then from the test set evaluate if the model has learned the underlying structure, underlying patterns, not each sample itself. And actually that process is called overfitting. We will look at these things a little bit more later in the next lectures. So basically, it's usually split in 80-20%. There might be also the third data set and so on. So the model architecture is based with these boxes, and this is if you anytime see the boxes, these are just mathematical functions. They don't write equations; they just draw boxes. And then there is a missing piece here, which is the hyperparameter search missing piece from most of the solutions that people do online. So, for example, if you are ordering, like in Upwork or some other platform, some AI model for you, then developers might just go inside GitHub, which is this source code repository. You might be heard of this, and find some model, mathematical part which fits for the task. For example, you want to have image segmentation. For example, you have camera on let's say on some kind of passage, on the bridge, for example, and you want to see how many people cross the bridge during the day. And then you deploy this camera, this image feed, and you might use the YellowRobot model. This is the name of one of these mathematical models. And somebody would just take from GitHub and apply and train the model on your dataset. Maybe these people are, I don't know, they're wearing strange hats, for example, and the model might not recognize them. So you need to have to train them on people with hats. So, but the problem is that most of the developers would just take it and train it. But the reality, what you need to do is to do the hyperparameter search, which means that the models, it's not enough. You need to check every single combination of parameters inside there, hyperparameters, and train every time the new model and get the best model out of this. And if you imagine that basically this is like a quadratic exponential number of experiments. So this is a huge number of experiments just to train one model. And normally people don't realize that you need to do this. So, and basically, if you do this properly, then you optimize your weights. Basically, you have those coefficients, they are called weights, and you get to some kind of global, semi-global, local optima. Basically, you don't want to be stuck somewhere where there is a high error rate, but you also will never get to a place where there is no error rate as well. So you try to train this and validate on your dataset that you did not give model for the training. To do this, you definitely need GPUs. Basically, on the top you see this NVIDIA GPUs. So this is graphical processing units. They were originally used for computer games, and this company NVIDIA last year became the $6 trillion company, larger than or the same size as Apple, and it was predicted that it will be much larger than actually Apple and other companies because basically what they did the last 10 plus years, they were investing money not on the hardware but on the software side. They were making that these GPU units can do AI related mathematics very good, so like in very efficient manner. So any other manufacturers that are trying to enter this market, like Intel tried to do this, Intel Habana failed, the AMD is trying to do this, also failed. So basically there is very hard for other competitors, it's very hard to get inside that market nowadays because all of the mathematical models are basically run on this CUDA platform. So yeah, if you want to like invest somewhere where there is like quite sure that like you can make money, then NVIDIA stocks is something that you might consider. So that's that. I need also now to add this this additional slide which I promised you. Let me try to. This will just take a second. I want to show you that these models are not black boxes. I will just jump for a quick second to other presentation. If my computer will open it. Just a second. Okay, I found it. Okay, cool. Okay. So yeah, let me show a couple of examples why they are not black boxes. So let's see, presentation, keynote, cool. Okay, let's go in. So here's like a popular dataset called Pascal Walk for image classification. So you give model the image and the model says what is on the image. So and then here you can see on the left side the image with the horse was classified as a horse. That's no surprise, right? And then you train a model with that image. And then when you have trained your model, you save the model and then you use it in inference. Basically, the model is trained, you don't touch it anymore, and now you can use it millions of times for the production. And that's how actually the ChatGPT also is being used, that it's used in production nowadays, right? It's not training from what you input in ChatGPT. We will talk about these things about data as well later, but basically they are not continuously training. The training process is very expensive, as you saw with the GPUs and so on. So, but then when I run this model, and if I'm having the, let's say, grass there, and then there is the Ferrari there, and I add this text there, it suddenly classifies this image as a horse, not as a car. So, and why this happens is because all of the pictures with the horses, with the photographs of the horses, is also signed by the same photographer. There is one woman who is making nice pictures of horses, and she's always writing her signature on the left side of the picture. And then if I add the same picture to another picture where there is no horse, it will always think that that's a horse. And if I take off the signature, like in two pictures below, then it's not able to classify as a horse. So this is exact way how AI models are being trained. Basically, any AI model will do this. These deep learning models, they try to give you the kind of optimal, the easiest solution for any given input. Is this an image, text, audio, whatever? The model don't understand about the world, right? There is no world models in most cases or something like that. The model just sees the data, the image, and gives the output of what you want it to learn. So in this case, because all of the horse images had this signature, the model learned that signature means horse, basically, because it's more difficult to detect different kind of horses rather than always the same font signatures, basically. So this procedure, it's called like stochastic gradient descent or optimization, where the model always does the same thing. And it actually, basically, it is also in the nature even. If you look how lightning strikes, right, by the least resistance, or if you pour out water on the table, the water flows by the least resistance. The same mathematics how this least resistance happens is also in the deep learning models. Basically, they also will do all of the things you ask them to do by the least resistance of data, basically. So, and I'm saying that this is not a black box. So if you would ask somebody to build AI model for you, and this person would not be educated, they would just train this model and give it to you, and then the cars would be classified as horses. But you should know that proper data scientists could also always make black box models white boxes. So they can look using the, let's say, class activation maps, grad cams, all sorts of methods inside the weights or how the weights operate. And here you can see if I give a picture of horse with this signature, there is this red dot, red spot here, and this is the activations of the features basically in that area of image. So, and if I'm doing a proper AI model, I should check if it activates there or activates over the horse, for example. So these things always have to be done before you ship model to your in the production. So, and there's not only in the images, there is also in other types of data. If you have, let's say, sales data in tabular format, you can also make it a white box to say why exactly model did something. There's also another example. So let me show another example. So we have we trained in the supercomputer some years ago a new reinforcement learning model. So this is this very annoying computer game, basically with a Flappy Bird. For human, it is super annoying because if you make one mistake, you lose, right? But computer, like this deep learning model, machine learning mathematical model, learned to play this perfectly without any mistakes. And how it learned to play? It learned to play by watching the video stream. So it could actually be real phone playing this game and artificial finger clicking it. But in this case, this is in a virtual environment, right? And based on rewards. So every time when bird earns points, the model knows that it did something good, and if it loses, it knows that it did something bad. And if you run this experiment, like for, I think it was 20,000 times or something like that, the model learned perfectly this. And this is also not like a black box. You can see in the beginning of the training on the left, the areas where bird thinks that this is a bad area to be, and on the right side after the training. And this is also what normally AI data scientists would do. that if you ask to build some kind of AI system, you need to validate that the model learned the right things. Because in this game, actually, was the Python learning, so this is Python learning environment game, replication of the original Flappy Bird game. There was a bug, so like a mistake in the game, that you were able to fly over the pipe. So, and we saw this also in the images, that there is a green part there, and then we discovered there is a bug. So this is a very important process, that to always check that the model is giving the right answers, making it white box. So also the 3D games, like there is attacking some kind of monsters, right? And you can shoot back on them. I think there was also video where you can shoot back on them. So, and there's also the labyrinths, right? Mazes, large mazes where you need to find red doors, right? And you also make these white boxes. So you make sure that the model is paying attention, like in the left corner, to the red doors, not, for example, to the ceiling or the floor, something like that. So that's another interesting aspect to be so you know, right? So that models nowadays, these AI models, they are not black boxes, and you can make them in many ways, white boxes, and people actually are even modifying trained models. They're able to, for example, to make language model to respond in particular way even after the training the model. So that's that. So now we are with a business application. So this is the fourth industrial revolution for sure. Basically, I think very few people disagree with this statement. So that if you look back in the past, and this is actually exciting time to be living, right? Because the last industrial revolution was in like 60s, 70s. So the first one was the invention of the steam engine, right? Then and also mechanization. So, and then the second was the mass production, when you have the Ford lines, right? And you had the electricity and oil-based power. And then third revolution was 60s, 70s, where there was a first robotic production lines, electronic-based production lines. And nowadays, this is basically AI-based, like all sorts of business processes, robotics. All of the robotics that were not possible even like 20 years ago nowadays are possible. But it's only the question is, do we need to do this? Basically, in many business cases, it is cheaper to do something by human workforce rather than build these advanced AI systems. But it is possible to build them. 20 years ago, it was not possible to build them. So this is like the new electricity, and we can imagine like in more than 100 years ago, when the New York City Expo was first time lit by electricity, like electric lightning. Before it was oil lamps, candles, and so on. And nowadays, 100 years plus after, we cannot imagine like any kind of business without electricity, right? And this is also kind of parallels with internet, mobile phones, and so on. So, but at the same time, you need to know how to use it correctly. So there is a lot of examples where it has gone failed, right? Has gone wrong over years. Like for example, on the left side, the PayPal chatbot before the generative AI methods were deployed. Basically, when you told PayPal that you got scammed, it said great, so it's good day, right? So, but it's actually, you would expect something different. And this was because this was the old type of chatbots where you had to program intent, right, nuodums, and response. But this is nowadays all of the chatbots, modern chatbots, are not based on intent. Basically, they are based on different methods. We will look at those methods later. So if you see in any of your businesses you're working with or will work for, they would use chatbots with intent and response. This is something that you should not be using, basically. So then also, of course, image classifiers. usually those cases where something is wrong for image classifiers is because people who train the models don't understand the mathematics behind it. So if you need those AI people who train those models, look for people who are not programmers but who are actually data scientists and so on. So then also often people use these models to predict things they cannot predict, like for example Bitcoin price, stock prices, and so on. There might be some aspects you could predict like volume, right? But the applying these models for unpredictable processes, this is also a big mistake, because they are basically pattern recognition models. They are approximators. They cannot predict future, right? So this is also usually zero-sum game. You will try to do this and it will most likely not work. So then also people try to use AI for business cases which do not make money. Basically, there is this very popular startup from Estonia, Starship. They make really cool robots. I have seen them also in San Francisco, and you see in the background there is the old Soviet buildings. Even they drive around Tallinn. So basically, I like the technology. I like what they do, but at the same time, the business case kind of hard to justify up till now. Maybe in future when the governments will push for higher salaries, then we will start automating all of the jobs. So it will be kind of paradoxical, right? People will push for higher salaries and then they will get automated by AI, because basically the salary is the only reason why their job exists actually. So basically here the situation is that this robot that is the last mile delivery robot, which is very cool, it has taken 10 years, 200 million euros already, and it is hard to make money with it because of course somebody with a bicycle can do this cheaper in most places still now. So that's also to think about, should we implement some AI technologies in processes. Also, there we have seen interesting trend recently. I found this post on LinkedIn some time ago, where people are complaining that AI is taking away their intellectual job. For example, I want AI to do my laundry and dishes, that I can do art and writing, not for AI to do my art and writing so that I can do my dishes and laundry, right? Laundry and dishes. So this is, I think, this woman with the quote is quite famous already in the internet. But the reality is completely opposite. So if you look the previous slide and now this one, you should kind of realize that the AI will first automate the high-paying jobs, the intellectual work, everything that makes money. This is the first target to automate, not the things that do not make money. So in your business endeavors and anything you do, like creative work, whatever, be aware of that. Right now there is like thousands or hundreds of thousands of companies that are trying to automate every single intellectual work that is like highly paid, that is kind of repetitive. For humans, it's still kind of better to do things which are very unique. Like every time you have completely different situation. Like it's even difficult to describe sometimes those situations. Those would be kind of good jobs for humans up till now, but also no job is really safe in the future. But let's say writing blogs, making banners, creating like ads, like creatives, images, whatever, all of that is, as you see already, very automated. I know many companies that previously hired graphic designers for their work, and nowadays they just generate their content for websites and so on. And this is the same for text and many formats. Even the influencers get automated nowadays. If you look up, there's already many services where you can generate video influencers, like really nice looking people that will sell things for you which do not exist in reality. Basically, we'll look at those tools as well. So we have invented something serious, and we need to use it for good and not for destructive purposes. There's also lots of ways how to use AI for destructive purposes. Maybe if you're interested in that direction, we could change one of our following lectures in that lecture, that direction as well. But basically, let's see, before some statistical data from business. So before Gen AI, so this is about Gen AI publicly appeared with these first image generation models and language generation models around let's say 2022, something like that, 2021, earlier. So that is the earliest. Before Gen AI, all of the surveys said that jobs least likely to be taken by AI are all of the creative jobs: artists, musicians, therapists, lawyers, and doctors, so on. But then jobs most likely taken by AI is a cashier, driver, translator, and so on. I would agree on the right side. I think still those professions are very in danger, right? So cashier, driver, translators are done, basically. Translators should not be even this chart anymore. I know professional translation companies where they basically now use a combination of some models, and they have metrics that can prove that their translations are as good or better than any professional human translator has been working for 20 years in that profession. And then this is not Google Translate. There is much more powerful translation tools. So that's that. But then on the left side, I totally don't agree with that. And not only I not agree, but also experts after Gen AI. So after Gen AI, one of the first professions that could be replaced by AI is legal. Before it was said that it will not be replaced by AI. So all of the legal workers, right, the lawyers and people who work in that field, I already know there is, for example, one startup in Europe called Deep Judge. There's many tools and startups that try to automate step by step every single process in lawyers' work, for example, because looking up these legislation, right, and looking up previous cases and putting it together with a new case, make the best arguments and so on. This is something that with these intelligent language models, and not only language models, but there's many other models that put together can automate fully. So basically the jobs which can be automated nowadays: office administration work, legal, architecture, engineering, social sciences, financial operations, the sales, customer services. So with the sales, even also management, of course, with the sales also really interesting. I can show you later some examples, but you really can automate many parts of the sales nowadays. Even the mathematical computer science things, the programmers, this is also a huge thing. People don't realize that computer programmers is also endangered profession, because in the future there will be needed much less computer programmers. Basically, already if you give the right tools nowadays to computer programmers, they can do at least 30% more, but sometimes even 50% more the same computer programmer. So, and even you don't need super experienced computer programmers anymore. So, and also on the right side, you see that there is this survey about artists. So the artists are feeling that generative AI has taken their income. Basically, more than half of artists last year reported that they lost income because of generative AI. So, and all of the professions that you think will not be replaced will be replaced. The funny thing here on the left side, you can see in the bottom part, which are the professions which are least danger to the AI. So it's like plumbers, maintenance, the construction workers, and so on. So it's already bad that construction workers are super expensive, right? At least in Eastern Europe, their profession will become even more valuable in the future. But even they are not completely safe, because we already see so many robotic systems that start to automate their work, like for example roof tiles, layers, or like even robots for sandpapering the rooms and so on. So it only depends on how much it costs. If it costs like a significant value and it makes sense business-wise, there will be more and more robotic solutions, and robotics nowadays is the next frontier. I already see that nowadays, like I went to the Dubai GITEX conference, and I see that basically this is the moment where very little people realize that let's say in next 10 years there will be lots of robotic platforms empowered by these AI solutions that will be able to do human work physically as well. So that's where we are. And in regards to EU, there is the Eurostat data from last year that only 8% of businesses use AI in their processes, and in Latvia 4.5%. So why I'm showing this is because people are thinking that we are in the hype, right? So let me find where is my hype chart. So people think that we are in the hype, right? But we are in the hype only with these superficial solutions. So ChatGPT, generative AI, and things like that. This is a Gartner hype plot. It is like the usual way how new technologies gets adapted to the businesses. So initially there is this peak of inflated expectations, then there is some kind of failures, and then there is at the end productivity plateau, right? We right now, I would argue, are not yet on the hype. If you think we are on the hype, this is just because there are some superficial solutions like ChatGPT and things like that. But for businesses, we are just in the beginning. So, and to prove that, I can also have some survey data from locally from Eastern Europe, and you see that there were about, I think, 800 companies surveyed, and I used to see like over 90%. So the yes but not implemented. Yeah, so over almost 90% of companies say that they don't have any AI systems implemented in their business processes. Only 10% have implemented. Then, in your opinion, is the current hype around so AI will change the operations of the businesses? Even though, let's go back, even though 90% have not implemented, the over 50% says yes, that AI will change their business. Basically, almost 60, no, it's even not 50, over 60% businesses says that AI will change their business, but they do not implement anything, and even don't plan to implement anything. So, and what is the reason that 60% do not see clearly the application yet? So, and after this course, I want to make sure that you see the application. So, and you will not be left behind, because any business who's starting to do this now, like professionally, not just using ChatGPT, would get ahead their competition for sure in any field. Like, would it be accounting? Would it be legal? Would it be even medical? I already see that there are many activities in medical field where they, for example, structured, unstructured data, there will be for sure in future these AI agents for medical professionals and so on. So that's that. Then in the America, if we see adoption rate in America that compared to internet, so this is the business adoption rate, and compared to smartphones, so we'll see that AI is still very early. So nowadays there's different reports coming out. It is somewhere in between 20 and 50% of the businesses that have been already starting to use AI in the business processes in America, but I would more likely believe that this is a lower end prediction, because I myself, I'm working with many businesses and I see that the education level is very low nowadays for the AI. So, and this is the same as to think that, let's say, we can run business without internet, right? The only 20% of businesses use internet. That's absurd, but that's the reality where we are right now. And in the next years, it will change, and everybody believes that this will happen much faster than in internet. Internet, it took like almost 20 years to reach this adoption level. Then for AI, it will take lot less, like maybe 5, maybe 10 years, but all of the businesses will use AI models. So also the McKinsey report, and the reports which I show you, they are not like some kind of insignificant, like some kind of fringes reports. There is the Eurostat, there is McKinsey, there is Goldman Sachs. Everybody is saying the same things. So McKinsey is saying that by 2040, around like 50% of global current work activities could be automated. That's like the average prediction. So every single work that we do as humans nowadays manually, let's say in how many years, like about 20 years or so, will be automated, like half of those works. And in some cases, like if this technology acceleration would accelerate, we could replace even more activities. It doesn't mean that in the future there will be no work for humans. It just means that the work that we are being trained to do nowadays will not be the same work that we will get paid for in future. So that's why I also need to think about what kind of professions and we should go, and also like learn how to use these tools to not be left behind and see like behind the corner, right? So also Goldman Sachs is saying, so this is like even from last year, I believe that this year they have even higher this prognosis, but they say that by 2030, like 9% of the jobs will be either replaced or affected by AI on the whole global level. But because even just to understand that there is a huge portion of global workforce that even don't have access to the internet. So it means that all of the developed countries will have much more significant impact on AI. So it will not be 9%, it will be like a double-digit percent. So 62% of students, 62% of the teachers in British Computer Science Society says that it is difficult to evaluate the work for the students, and this was last year. Now I think if I do this survey this year, this will be again much higher. And I will show you in the course in next lectures that you could automate any kind of exam basically using these tools, so the evaluation of the work and also the like educational process has changed significantly. So also the Lithuania, our neighbor in the east, like here on the south in Eastern Europe, 94% of high schoolers already use ChatGPT to automate homework. So if any of you have kids that are in the high school level or maybe university, so especially high school, where you have some control over their educational process, just be aware of that all students know how to use these tools, and homework is kind of meaningless. I would say that basically, and even if the student is highly motivated to do the work themselves, they will always use these tools to just make sure that everything is correct. So basically, how I always say it, like for example, language models, ChatGPT, and so on, they are great tools, but they should be applied to the correct part of the education. For example, if I give mathematical calculator to the second grader and tell the second grader to learn the multiplication, the second grader will learn where is the multiplication sign on calculator, would not learn anything about numbers and how they work at all. So that's the same thing about ChatGPT. If you would give these language model tools to student and ask do some text-based intellectual work, they will not learn anything. And the project-based education, whatever, this doesn't work. So, but at the same time, if you give mathematical calculator to 12th grader, right, in physics with the 4-digit numbers, this is great tool because they can do much more complicated things. But then you must understand when it's like the 12th grade, when it's the second grade. And if you just know how to use mathematical calculator and you don't know anything else, you will not get a good job. And this will be the same with these language models in ChatGPT. So if any of your kids, high schoolers or so on, have homework and basically, I don't know, like even I talked with gymnasium teachers and we kind of agreed that homework is something that should not be done anymore nowadays. So, but yeah, that's a significant problem. So the elephant in the room, which highlighted by the last problem, is of course ChatGPT. And ChatGPT just 2 years ago reached 100 million global monthly users in 2 months. So I remember how it was in the early days. Like educational system was not ready for this. Like suddenly students who didn't know anything started to write like really detailed essays and with like complicated words and so on, because all of the students immediately understood how to use it. And even the other platforms like with youngsters like TikTok, right? It took 9 months for 100 million global users, but for ChatGPT it was instantly. And that's why maybe also it like contributed to this effect of hype, right? That everybody thinks that ChatGPT and language models and AI is already here, but there is still a long way to go. So if we compare some of the way how it grew. So initially it was this 3.5 model, which many people tried, and then they think that ChatGPT is weak and doesn't work and don't understand these smaller languages and so on. But the mistake was that many people tried it and not tried it anymore. But if you would buy the like a paid version, right, then you would already saw that these models on different exams. Here we have different exams like mathematics, biology, economics, and so on. With this free version, it was like about like 50%, and then with the paid version, it was already almost like 80% in most cases. So just by typing in questions, you would get perfect answers. And nowadays, what I showed you before, it was like true, let's say, half a year ago or so. Nowadays we have reached even next level. So the next level is if you pay for ChatGPT. Basically, again, remember GPUs, remember that this is super expensive to run, so you cannot expect for this to be free. Basically, if you pay for it, you get something that is really significant. Like OpenAI O1 model, when you give the intelligence tests, IQ tests, it surpasses the average humans. Basically, it gets 120 on IQ tests, and all of the models that were just half year ago, like best models, they are all below the average IQ. So this new model is capable of reasoning, capable of doing really complicated analytics, and so on. So you could just paste your questions, paste your problems. It will give you step-by-step detailed answers to almost any problem. So that's where we are right now. And ChatGPT, like it was also last year, already broke the Turing test. So if any of you know that Turing test was invented by this code breaker from the World War in UK, that basically it was idea that if you have two strips of paper coming out and there's numbers or text or some other human information made by human, right? So and if one piece of text coming out from the human, another one from the machine is indistinguishable and you cannot detect if that is a human or machine, then you pass that Turing test. And basically, with the ChatGPT systems, you can build easily all sorts of AI agents. For example, you could look at character AI. I will type it in the chat so you can look it later. Character AI is this platform where you can talk with historical personalities. So this is based on, just a second, I'm trying to type this in the chat. So let me try to see it. I want to make sure that I write it right. So for example, you could talk with Thomas Edison or any other historical person, right? And this is based on, let's say, we will talk about how to build these models later, how to use them. But basically you can upload the interviews, books, right? And all sorts of personal information, how these people responded to the questions. And then this large language model combination with RAG, retrieval augmented generation, can generate these super convincing, realistic answers to different questions, how this person would answer. So let me show you one more example. So this will be a sneak preview of what to come in the future. So we will have a dedicated section also on the prompt engineering, Whiteboard engineering. So where we will look at how this works in detail. But so I want to show you one way how language models work and what they are and basically what they are not. So if I'm just copying in some question from uzdevumi.lv or from where you have the exam questions in Latvian history, for example, if I just copy that question in, I get, in most cases, really watered down answer with just one number, 90-20. So if I would be a history teacher, I would give a low grade for that kind of answer, because I see that this is, firstly, I see that it's generated, but basically there is very little information inside there. There's just one factual number there. So, but if I go then and look up for some facts with numbers, so you can look up facts with numbers using search engines, but nowadays you will see in a moment that we have some things that are much better than Google or Bing. So basically, you look up for these facts. You could actually copy the facts from your own documents as well. You add these facts to your prompt, right? And then ask the same question again. And you should notice here that in the facts I have many numbers, right? And what happens is that language model will copy those numbers in answer in very logical or reasonable way. So we will look at how ChatGPT language models work, but they all tend to copy from inputs to outputs data points in a logical way, basically. So just if you know how to use it a little bit, you know, not just use ChatGPT as Oracle, but know how to play around it so that it works in your favor, you can create really high quality text documents, answers, and so on. And I can prove that to you because there's so there was one scientific research about scientific publications where like it was shown that in recent years, I think it was like 70% of medical papers were using ChatGPT basically for generating the medical paper. And how they know it? Because there was one single word called delve, which was in the OpenAI ChatGPT training set, and it was specifically there because they used Nigerian labelers for labeling, and in Nigerian language the delve is very oftenly used word. And then it was also in those papers, and it was not before. So basically, just as soon as ChatGPT came out, all of the scientists started using this method, which I'm showing you now, to generate scientific papers. So basically, we already are consuming ChatGPT outputs. So for the search engines, I showed you here, you should check facts from the search engines, right? So I would recommend something like this. You see there is no Google here. There is Gemini from Google, but there is no Google search engine anymore. So I have not used Google search engine for a very long time. I think I have not used it for over a year already. So, but instead I'm using the paid version Perplexity, and nowadays, just last week, the ChatGPT search came out. So if you go in the ChatGPT paid version, you would click the blue search bubble, and then you would be able to search using the ChatGPT as well. But originally, ChatGPT was not designed for being Oracle. So if you are using ChatGPT as Oracle, that is a big mistake. Please use the search function or any kind of search engine for that. But these are very powerful. Basically, if you start using one of these, you would see big difference, like how you would search for things. You don't need to open links. You just ask things, and it will summarize things with references, with numbers. It can create tables. I will show you many things about that. So, and just for the teaser, you can also go to there's an AI for that. In the similar how it was like let's say how many years it was ago, like let's say 15 years ago, they said that there's an app for that. Nowadays they say there's an AI for that. 15 years ago, people were thinking, why would anyone need apps, right? Why would your grandmother need app? Nowadays, every grandmother have apps, so like WhatsApps, whatever, like Facebook and so on. So and they know how to use Google. They should learn how to use Perplexity, but basically, so that's that. Then in the future, we will have huge number of AI apps, and we will use all of them all of the time. So let me show you a couple of also interesting applications, and next time we will start digging into more data specific things. I will show you at the end what is the plan. So for automation of analytical processes, what I mean by that, in the background of that image, I'm there last autumn in Novo Nordisk. This is a big pharma company, and they have these chromatography, mass spectrography machines. And previously humans who were learning for, let's say, 3 to even 9 years in university were educating themselves how to do the separation of compounds, like in some unknown samples. For example, you put in coffee and you want to see that there is a caffeine, you don't want to see that there are some pesticides and so on. So, and this is what these machines do. If you put in some kind of substance, they can split them into the compounds, and you see what kind of compounds are there. But to do this, normally it was done 2 weeks by humans. Now it's done in 2 hours by AI machines. So, and these companies have actually so much money. Like if you see a Novo Nordisk, I think they have like 3% of Danish budget. I think it was like the yeah. So and it was because they invented this Ozempic, the drug for like to getting thin, right, and lose weight, and they sell it to Americans. But basically, the AI is making their life easier. Basically, they can just press one button. It does things that are intellectually challenging. So also for the manufacturing process, I have been personally, and what I'm telling you, all of these projects I have been personally involved. So it's where you deploy AI for, let's say, there is one project with Zippy Vision where you deploy it on machines who cut wooden planks automatically, basically, or we have lots of wooden industry here in Eastern Europe, and many processes in factory floor can be automated, and people even don't realize how many processes can be automated. Like any part where there is a little bit of intellectual work can be automated, and mechanical work, of course, also can be automated. Then quality control. Quality control is really tricky one, because I have seen in many cases in the factories and manufacturing facilities where they basically either they deploy quality control and then they realize that they don't need it, because usually, like, even the human who is not able to spot all of the defects, basically the product is then sold to the end user, and they often don't complain. Only if the product is so bad that basically nobody buys your product, maybe then you need to deploy either quality control or improve the production process. But quality control can be super easily done with AI. Basically, you can catch 100% or almost 100% any defects in any product, but in most cases it is not economically viable, because at the end nowadays production is not that bad, and the customers really don't care about quality in most cases. So it's I have yet to seen some company where they actually care about quality. Often I had situations where, for example, they deploy something, then they decide they don't need quality, they remove it. So this is kind of situation. So also for resource and demand forecasting, if you're running some shop or logistical operation or anything, and you don't do predictive forecasting, that is like throwing money in the toilet, basically. So because you don't want to have stocks based on your intuition, right? You want to have your stocks based on data, and you can do this nowadays easily. There's like tons of software out there that can automate this process super easily. So for logistics optimization as well, in Eastern Europe, I still see that many services do not use any kind of AI systems for their routing. Like the best case, they would just use Waze or something like that, but it is not like a calculated way. So, but if you deploy these things, you can save a ton of money. So then also document reading. Nowadays, nobody should type in documents manually. Like either this is a printed document or handwritten document. These can be digitized super easily nowadays. Any language, any format. It's just if in the business process there is somewhere like a physical text, papers or something, and somebody types this is like wasting time. Basically, you can easily automate these things. Then also tracking. There is also a funny example from the left side where there is the tracking of EU Parliament, and somebody deployed how many hours, or like what is the percentage of the work time politicians spend on looking at the phone. There's one guy 85% of the time looking at the phone, so not paying attention to the session at all. But you could, and I know lots of companies who deploy these systems, for example, in shopping malls. Like also the shopping malls are not using this, they are also kind of losing money. Basically, they can optimize how they place things in the factory floors and so on. The security applications, nowadays also, so the one is just to deploy cameras, right, with built-in AI systems, so right, where they detect the intruders and objects. But also nowadays, I see movement towards robotic systems where you can like almost fully replace human guards with robots. Basically, there are already. I think I know myself at least 5 companies who do this already, and it is not cost efficient for Eastern Europe, but it is cost efficient for Western Europe already. So, and robotics. Robotics also, they are not the robots which I showed you from the third industrial revolution. They are not robots where you need to program things in Robot Studio. This is totally not that. Nowadays, robots can work together with humans. The things which can be, misplaced, wrong shape and so on, and they could pick them up and place them without any kind of sick days, day and night, and so on. So the robotics also have been transformed using the AI basically, and not many companies have yet implemented these advantages. And then towards the end, I want to share you one big piece of AI automations which we do for living in one of my companies. So this is automation of communication. So the example here is call centers, contact centers, where you have hundreds of human agents, some in the workforce. For example, the best contact centers actually are those where every month there is rotation of the workforce because they are pushed for higher KPIs basically. So there are humans on the lines, there are quality control humans, there are text message responding humans, there are marketing team, there's all sorts of humans there, and generating kind of huge cost. And then if you deploy the systems that we are working, then you can get like half of them replaced by AI robots basically. You can have AI enabled staff training, quality control, robot colors, the generated content, all sorts of things, AI automated emails and so on. So when we have done this for a number of companies over years. So, oh, this is in Latvian, sorry for that, but we have, I would say, the best AI analytics system for call centers, where you can detect the soft skills in the calls, like if somebody is angry, right, or sad or happy and so on, and also the hard skills. For example, if somebody complains about price, right, then, or it's an objection of the price, then the agent should offer a discount or ask for a budget or ask when we can call again. And if the agent does this, they get points for this. Basically, the agents, human agents or AI agents, get motivated to achieve the KPIs. So every single activity in the written, audio communication, in all of the communication gets rewarded by points. So that's that. There is also a deep analytics. You can go very deep in all of the metrics. And there is also the other part, LDGen, which is the plug and play text agents. So there is the client support agents, which are deployed in Tele2, for example, where you can write the chat messages and email messages, and they get completely automated by AI. And then if there is something that they cannot respond, then instead of programming some kind of intents and rules, the system owners get notification that they need to add more information to your data set, right? So like somebody could not answer a question about particular service, then they need to add description of that service, and next time the agent will be able to respond. So also for the web shop, they got higher sales also with this, and automated people who makes the descriptions and structured data inside the web shop. Instead of basically somebody entering these details, the AI agent goes and picks up this data from qualified sources and puts it in the web shop automatically. The same goes also for generating like social media posts and things like that. Then also staff training. For staff training, also very cool. You can just drop in videos, presentations, and it would generate the whole course for the staff training automatically, and you would see how much each person in your team knows the product and where are the problems in their product knowledge. So that's also Eldigan. And then finally also document checking agent, which is checking the documents against the criteria and qualifies the documents and pushes them in the pipeline. So for example, if some kind of CV comes in, you check if that CV matches the criteria, and then you move it further away. And yeah. And where we are going is this workplace of future, where you will have a lot less human workers and a lot more AI workers. So you will be the kind of department manager or the business owner, human, and around you will be all of the team with AI agents. This is basically where we are going very fast right now. So, and examples like this already exists, like for example Blossom Reads or Stasdm.com, where you can upload, for example, your child's photos and descriptions of what the child likes, and it will generate this customized book as a gift in physical format that you will receive in the mail. I know the guy who makes this startup, this company, and he is not a book designer. He is basically the computer programmer, data scientist. And he is kind of like this solo entrepreneur because he set up this whole business using these AI agents, and he don't need to, design these things. They're designed automatically, put together in really nice way, and he just checks that everything is okay and ships them out. So businesses like these will be much more in the future. And I also want to give you some hints where you can find more information till the next time. So for example, we have the Artificial Intelligence Association, MILA.lv, where you can actually find seminars. So there will be a new seminar coming out. Actually, I need to write down, so the guys put the seminar on the website. And this seminar will happen in person in Z Towers in Riga. And this will be, I think, the first one will be for HR department. So you will learn about AI tools, how to automate work in HR. And there will be many departments that we will cover how to automate work in those departments. So definitely check out milo.lv if you're in this Eastern Europe where we are right now. So that's that. Then I also have another YouTube channel, not this one where I do the courses, but another one, AI Ranch, where I show ChatGPT tips and interview business people, how they applied AI to their businesses and achieved great results. So definitely check out that. And if you have some questions, write on my email as well. And regarding the course, so next time we will look at something that is more in towards the data. So we'll look at how to process normally data to feed into the AI models. So if you do that data processing, you will get better results also with ChatGPT based data processing or any other AI system or professional AI system. So we'll look at data processing, visualization, dimension reduction, structured data, and so on. So, and next time after that, we will look at these 90s technologies, clustering, categorization, decision trees, and so on. These are also really good. Need to know how they work so that you know in your business cases how to apply them. Because basically the number 3, these methods which are covered in number 3, they are great if you have limited data, if you don't have endless amount of data. Because all of the other methods, like the artificial neural networks and so on, require large amount of data. They are excellent, but they have some limitations. So then afterwards we will have natural language processing, the prompt engineering and things like that. Then we can also cover image processing, video processing, audio processing, robotics reinforcement learning, hardware, software regulations. So we'll see if we get so far. And probably I will need to combine some of these courses. I will think about it, how to combine them. Maybe for the next time, I will combine the second and third together, because I want to try to make it also as much as interesting and useful for you, but at the same time we need to cover some basics, so we're not doing like stupid things with these models. So that's that. Also we will cover okay, something went down, okay, but you can see it still. So also we will cover different data domains. So we will look at tabular data, structured data, unstructured data, time series, text data, image data, video and audio data. So that's what we're planning to do in this course. Hopefully you learned something new today and get hopefully excited about what's coming up for all of us in terms of AI. So if you like so far what you have heard, you can leave some like, and basically we can meet then next time. Okay, I will make a poll in the Moodle. Please make sure that you all join Moodle. I'll also add the Moodle link publicly in the YouTube. Maybe if I get flooded with people from outside the university, then I will close it. But basically, please fill the poll, right, in which day and time you would like to have these courses. Next time we'll dive into the data, then the artificial neural networks, then the prompt engineering, and so on. Okay, so let's meet you all next time. Okay, bye-bye.